What's the most mind-blowing and mesmerizing science fact not much people know about? Near the center of the Milky Way, there's a dust cloud known as Sagittarius B2. This dust cloud is really big, almost 150 light years across, and has a mass about 3 million times that of the Sun. Spectrographic analysis has shown what it's made of, and it has fairly high concentrations of both ethanol, which is what gives you the buzz when you make a cocktail, and ethyl form a compound which has a distinct smell of rum, and is also one of the compounds that gives raspberries their taste. If you could condense it down to level where it was detectable, then the center of the galaxy would smell not dissimilar to a raspberry daiquiri. This sounds like something straight out of Hitchhiker's Guide to the Galaxy. If you take two different types of metal and hold them together in space, they will bond together in a process called cold welding. I loved how a friend of mine explained it. Then the two metals touch and there is nothing in between. So the electrons start going out for a walk and they become confused because they don't know where one piece of metal ends and where the other one begins. So they wander around both and boom, now it is just one piece of metal because the electrons don't know where they are. Humans are bioluminescent and glow in the dark, but the light that we emit is 1000 times weaker than our human eyes are able to pick up. Source: poor humans. Their glow is so lovely and they can't even see it. The images your eyes give are 1/100th of a second in the past, because of the time it takes your brain to process inputs from all senses. What is happening in front of you is 1/100th of a second behind. Yeah, it's crazy how the present doesn't actually exist. It exists, I just don't think you're observing it yet. Sharks existed before trees and grass, right? Grass wasn't around either. All those dino movies with lush grassy floors, it wasn't there. Oddworld, ferns everywhere. Eventually the grass displayed them. If Betelgeuse, a fairly nearby giant star, goes supernova, it will light up our sky for 2 months. The really freaky thing is that if it went supernova today, because of its distance, the light wouldn't reach the Earth for over 600 years. What if it went supernova a couple hundred years ago, and we just don't see it yet? Would we experience anything before seeing it? Water can boil and freeze at the same time. It's called the triple point, and it occurs when the temperature and pressure is just right for the 3 phases, gas, liquid, and solid, of a substance to coexist in thermodynamic equilibrium. https://www.youtube.com watch v = mp6mvlw my man boiling ice over here. I'll be sure to check that link when I get home also. That does sound really cool. Astronomer here. A supernova is a star that is massive enough to explode at the end of its life. And one single star that undergoes this process can briefly outshine a galaxy. The crazy thing is we would know about it a few hours before the light would reach us. This is because a supernova is triggered when the core of the star collapses under its massive weight. And in the core you get a neutron star created. And that process releases about as many neutrinos as the sun. Neutrinos are particles that don't interact much with matter, unlike light. The light, on the other hand. So basically all the neutrino detectors on Earth would suddenly go haywire from more neutrinos than we have ever seen. And that will tell everyone to run outside and try to be the first to see the first galactic supernova we've seen in centuries. You can sign up to receive the alerts BTW. Holy sh, that is amazing. Looks like light has a new competitor. I'm definitely signing up for that though, and I hope someone gets this on the front page of Reddit. There's a number called Graham's number, which is the upper bound to a mathematical problem. It's also a really big number, and by really big, I mean special notation was derived just to write the damn number. It is so unbelievably large that if you inscribed every atom in the known universe with a digit, you would effectively be 0% of the way to the number. And if you were able to conceptualize the number in your head, the information density could quite literally cause your head to collapse. And it's not even the largest mathematical number. That goes to a number called 3, which is even more insanely huge. Fun fact, in Magic: The Gathering, there was a long-standing challenge to create the largest finite amount of damage in a normal 60-card deck, assuming the opponent does nothing. Finite is important because it's dead easy to make infinite loops in Magic, or rather, loops that can be continued for as long as you like. Creating a deck that can do an extremely high amount of damage, but cannot go infinite, is very difficult. Someone found out how to do more than Graham's number of damage in standard. The deck with the full card set makes that number look like peanuts. Jesus, I read that article and that's insane. I've never played Magic: The Gathering, but the fact that someone managed that is ridiculous. We humans and our arbitrary challenges. LMAO. The mass of the sun makes up 99.98% of the total mass of our solar system, and Jupiter takes up most of the remaining mass, so I'm going to guess Jupiter doesn't move the center of mass that far away from the center of the sun, based on the mass. You can't feel the temperature of things you touch. Scenario: you take a shower. Once you are done you step on a carpet. It does not feel cold, but you step on the floor, usually ceramic. It feels cold, but both objects were in the bathroom as you showered and so they both are at room temperature. What you feel then is a heat transfer from you to the object, one being a bad transfer because of the pockets of air in the carpet and the other being a very good transfer with the floor. So what do you really feel? What can you really tell from touch? Similarly, you've never actually touched anything in your entire life. The electrons in both your body and the other object repel each other before you can make physical contact, so you only ever feel that force from the electrons, not the object itself. We proved that the Higgs boson, one of the smallest elementary particles, actually exists by building a 17 miles, 27 kilometers, diameter tunnel and shooting photons at each other. This thing existed for a fraction of a fraction of a fraction of a second and is literally one of the smallest things in the universe, and we were able to observe it. Protons, not photons. You can shoot photons at each other with 2 flashlights. Some turtles can breathe through their anus. Yep. You can build a device at home for about $30 to see subatomic particles. It's called a cloud chamber, and muons from cosmic rays, or alpha particles from americium taken from a smoke detector will leave trails of condensation that you can see with your own eyes. I'm writing this from the taxiway, so I can't link any videos right now. If there is interest, I can try to link some videos later. If you get a chance, please try to link some videos. It sounds very cool. Most people know about the big red spot on Jupiter. What most people don't realize is that the spot is a huge storm that we've been watching since 1830, and suspect it's over 350 years old, and that storm is larger than the entire freaking planet Earth. Yeah, doesn't the spot fit like 2 Earths? Google source code has 2 billion lines of code. To be fair, that's not that surprising given the complexity of the search engine. Still a giant number though. I'm just reading Bill Bryson's new book The Body, A Guide for Occupants, and every single page contains mind-blowing and mesmerizing facts. To wit, for each visual input, it takes a tiny but perceptible amount of time, about 200 milliseconds, 1/5 of a second, for the information to travel along the optic nerves and into the brain to be processed and interpreted. 1/5 of a second is not a trivial span of time when a rapid response is required to step back from an oncoming car, say, or to avoid a blow to the head. To help us deal better with this fractional lag, the brain does a truly extraordinary thing. It continuously forecasts what the world will be like 1/5 of a second from now, and that is what it gives us as the present. That means that we never see the world as it is at this very instant, but rather as it will be a fraction of a moment in the future. We spend our whole lives, in other words, living in a world that doesn't quite exist yet, or, the fact is that odors and flavors are created entirely inside our heads. Think of something delicious, say moist, gooey, warm chocolate brownie fresh from the oven. Say, take a bite and savor the velvety smoothness, the rich heady waft of chocolate that fills your head. Now consider the fact that none of those flavors or aromas actually exist. All that is really going in your mouth is texture and chemicals. It is your brain that reads these scentless, flavorless molecules and vivifies them for your pleasure. Your brownie is sheet music. It is your brain that makes it a symphony. There are more ways to shuffle a deck of cards than there are atoms on the planet Earth. Kinda find this one hard to believe. The way you perceive the world is based on your upbringing and the interactions you get in the environment which you are in. Every decision you make is a result of experience. The majority of people are oblivious to this and live their life unaware of how their past and the environment they are currently in, along with the social circles around them, influences their future. Looks at parents. So this explains microplane anxiety, hypervigilance and lack of emotional immaturity. If we condense the life of Earth to 1 year, humans wouldn't appear until the 31st of December at 11:58 p.m. We think a year is a while. It's nothing compared to just the life of our own planet. Jupiter and the Sun's center of mass actually reside outside of the Sun, technically making them a double system because they both orbit around their shared center of mass rather than Jupiter orbiting the Sun. Except Jupiter isn't a star, so we don't bother with calling it that, even though we'd call two brown dwarfs a double system. A fake Jupiter is also about as big as planets get. Adding much more mass actually makes it start shrinking. Fake Jupiter is also about as big as planets get. Adding much more mass actually makes it start shrinking. Not quite. You could get to around 1.3x to 1.4x Jupiter's size before the nuclear shrinkage starts. But some hot Jupiters that are heated by a star can get inflated to upwards of 3x the size of Jupiter. Yike. But any given spot on our planet's surface gets darkened by the moon's shadow on average only once about every 400 years. The sun's diameter is about 400 times that of the moon. The sun is also, on average, about 400 times farther away. As a result, the two bodies appear almost exactly the same angular size in the sky source. During the last solar eclipse, I read that our planet in particular would be a huge tourist destination in the event there ever was interplanetary travel. The odds of a planet's moon and its star having the same angular size is so rare that Earth is probably the only planet in the Milky Way to have a perfect total solar eclipse featuring a view of the sun's corona. Quantum physics is seriously weird. There's a non-zero chance that in 10 minutes you'll be on the moon, or the middle of the sun, or the other side of the universe, or maybe it'll happen in 30 years, not 10 minutes. The chance is stupefyingly small, but it isn't zero. The chance goes up the smaller the mass and shorter the distance. It's only actually relevant at atomic distances and electron masses. A potential reason for the apparent lack of nearby intelligent alien life is that it hasn't had time to develop yet. The number of coincidences that had to occur for even single called life is unbelievable, but more importantly, it took a mere 4.5 billion years for an environment to arise through evolution that rewarded intelligence rather than simply being stronger, more physically adapted. Also, about 3.8 billion years of that time was spent by waiting for bacteria to convert CO2 into oxygen. We may end up being the most ancient alien race in the local area by millions of years. I've read that the sun is within the first 5% of stars that will ever form in the universe. Any future intelligent life forms that happen upon us or the ruins of our civilization will likely envy us, since we were able to observe the universe while it was still so young. On average, the closest planet to Earth is Mercury. The same is true for every other planet in the solar system. I love CGP Grey videos. Haven't seen this one? Amazing. I will use this information to assert my intellectual dominance at gatherings. If you keep upside down vision for a while, your brain will correct for it and you will see the right way up again. This is because your eyes see stuff upside down and your brain corrects it. You're basically relearning how to see. Yeah, I've heard that some basketball team did that with some glasses and actually got used to it. It's really crazy how learning works. Every stegosaurus was already fossilized. That means that on a timeline, T-Rex is closer in time to Keanu Reeves than to the last stegosaurus. I work on 2 dinosaur digs most summers. One is in 145 million year old sand rock in Utah and the other is in 66 million year mudstone in Montana. It's weird to think that I'm 15 million years closer in time to the dinosaurs in Montana than those dinosaurs were to the ones in Utah. I learned this from a friend on my business course. The same chemicals that onions emit that makes us cry is also the same chemical that makes volcanoes erupt. Here's why onions are the most metal veggie on earth. The chemical they release irritates our tear gland because it reacts with our tears to produce sulfuric acid. If the sun was shrink down to the size of a marble, the gravitational forces would collapse and become a black hole. I always thought this was mind-blowing, as gravitational pull is determined by mass. Picture 2 points on the globe, exactly opposite to each other, or, to put it another way, antipodes. Only about 15% of points on land have a land-based antipode, making up about 4.4% of the world's surface. So if you want to make an earth sandwich by having 2 people drop a piece of bread on the ground simultaneously, you're limited in options. There is, as an absolute minimum, at least 1 pair of points on the Earth's surface at any given moment that have the following properties. They are antipodial, directly opposite each other on the planet's surface. They have exactly the same temperature, down to the most infinitesimal fraction you can imagine. They have exactly the same air pressure, down to the most infinitesimal fraction you can imagine. The reason for this comes down to something called the Borsuk-Ulam theorem. Basically, because temperature is a continuous scale, you can't get from 28 degrees to 26 degrees without going through 27 degrees, then there must be a continuous ring around the world, however wobbly, that divides the surface area exactly in half, while all antipodial points on that line have the same temperature. Whatever that temperature is, it can vary from point to point. As air pressure is also continuous, it must have a different line that divides the planet in the same way. Because both of those lines split the planet exactly in half, they must, mathematically speaking, intersect at least 2 points, and those points are where the above statement holds true.